There is a place on Earth where water cannot
Look at the
reach.
size of those rigs.
A land surrounded by mountains,
They're completely
locked
hidden.
away from every ocean. Millions of people, no access to the sea. For centuries it stayed that way. Then someone looked at a map and asked a question no sane engineer would ask. What if we just cut through? Not a road, not a tunnel, a canal. Through some of the most violent terrain on the planet. Through earthquake zones, through salt deserts, through mountains that have buried armies. The price tag? Over $1 trillion. The timeline? Decades. The risk? Total failure. And yet, the blueprints exist. The surveys were done. The ground was tested. This is the story of the most audacious infrastructure project ever conceived in the Middle East. A canal that would rewrite trade, power, and survival for an entire region. It should not be possible. Every expert said so. But the mountains were only the first problem. Iran sits at the crossroads of the ancient world. But there is a problem no one talks about. A problem carved into the land itself. Iran's central plateau, the heart of the country, sits completely landlocked, surrounded on every side by mountain ranges that have stood for 50 million years. The Zagros to the west, the Alborz to the north, the Makran ranges to the south. Moving goods in and out costs Iran billions every year. Every container, every barrel of oil, every ton of grain, forced through mountain roads, forced through narrow passes, delayed, taxed, slowed. Then, in the early 2000s, a senior government engineer sat in an office in Tehran. He pulled out a topographic map. He traced a line from the Persian Gulf coast northward, deep into the interior. 650 kilometers. That was the distance. 650 kilometers between the sea and the landlocked cities that desperately needed it. He passed the proposal to his department chief. The chief stared at it for a long time. Then he said one thing: the geology alone will kill this project. And he was right. Because when the first geological survey team was sent into the field, they came back with something no one expected. The ground beneath the proposed route wasn't just hard, it was alive. The survey team had spent 6 weeks drilling into the proposed canal route. Core samples, seismic readings, ground stability tests. What they found stopped the project cold. The entire corridor, all 650 kilometers, ran directly through one of the most seismically active zones on the planet. Iran sits where 3 tectonic plates are constantly grinding against each other. The Arabian plate, the Eurasian plate, the smaller Iranian microplate. Every year the ground shifts. Not metaphorically, literally shifts by several centimeters. The lead geologist on the survey team filed his report in 2004. It was blunt. He wrote that building a water canal through this corridor without it cracking apart within decades was, in his words, an engineering problem without precedent. But that wasn't the worst part. Buried beneath the route, in the Zagros fold belt, engineers discovered something they hadn't planned for. Massive underground salt formations, hundreds of meters thick. Salt that dissolves when exposed to water, which means build a canal through it, fill it with water, and the ground beneath would literally eat itself. Sinkholes, collapses, entire sections swallowed underground. The original plan was dead. The chief engineer was replaced. A new team was brought in, quietly, without announcement. They were given one instruction: find another way. They studied the maps for months, and eventually, they found a corridor, a narrow geological window that avoided the worst of it. But using that corridor meant something far more dangerous. It meant going directly through the mountains. The Zagros Mountains are not ordinary mountains. They are folded, compressed, layered like crumpled paper pressed by unimaginable force. The new corridor ran straight into them. To connect the Persian Gulf to the interior plateau, engineers would need to punch through over 90 kilometers of solid mountain rock. Not around it, through it. The proposal called for the longest canal tunnel system ever attempted in history. Longer than the Channel Tunnel. more complex than the Gotthard Base Tunnel. But unlike those projects, this tunnel would carry water, millions of cubic meters of it, under constant pressure, through fractured, unstable rock. The pressure alone could split the tunnel lining like a cracked pipe. A Swiss tunneling consultant was brought in to review the plans. He spent 3 weeks on site. He examined the rock samples. He studied the fault line data. He ran the pressure calculations. Then he sat down with the project director and told him something that didn't leave that room for years. He said the tunnel could be built, but at 3 specific points along the route, the rock was so fractured, so unstable, that any miscalculation would not just collapse the tunnel.
It would trigger a chain reaction, destabilizing the mountain above. An entire ridgeline gone. The project director didn't cancel the plan. He made a decision that shocked the engineering team. He approved it anyway, but added one condition nobody saw coming. A condition that would change everything about how the tunnel would be built and who would build it. The condition was simple. No foreign contractor would lead the tunnel construction. Iranian engineers only. It was a political decision as much as an engineering one. Sanctions had isolated Iran from Western technology for decades. No Caterpillar equipment, no German tunnel boring machines, no Swiss engineering firms allowed on site officially. The project would have to be built with domestically sourced expertise, and whatever could be quietly imported through back channels. A team of engineers from the Tehran-based Tunneling and Underground Space Association was assigned the contract.
See how it just flakes
Most of
apart?
them had never managed a project at this scale, but they had something the foreign consultants didn't. They knew this geology personally. They had worked in it, studied it, watched it fail before. The tunnel boring began in the southern approach, from the Hormuzgan province side in the dry season. The machines moved slowly, 3 to 4 meters per day through the hardest sections. Then, at kilometer 34, the drill head hit something unexpected, an underground aquifer, pressurized.
This whole
hidden,
section is missing.
Completely
It's absent from every map we've
survey
checked.
map. Water exploded into the tunnel shaft at over 400 liters per second. 3 workers were evacuated in under 8 minutes. The shaft flooded within the hour. Equipment worth millions submerged. The tunnel director stood at the entrance, staring at the water rising inside. He had 2 choices. Abandon that section entirely, which would add 40 kilometers and 4 years to the project, or go through the water. He picked up the phone and called one man, a retired engineer who had faced something like this before, in a project the government had never officially acknowledged. The retired engineer's name was Dr. Karim Tehrani, 71 years old, semi-retired, living quietly in Shiraz. He had spent his career building water infrastructure in impossible conditions. He arrived on site within 48
hours later.
He walked
The main
to the
access
flooded
tunnel
shaft entrance,
completely submerged.
didn't speak for several minutes. Then he asked for one thing: the original seismic survey data. Not the revised version, the original. What he found inside that data had been overlooked years earlier. The aquifer wasn't random. It followed a fault line running diagonally through the mountain, which meant the water wasn't just in that section. It was connected to a much larger underground reservoir sitting directly above the tunnel's planned route. If they drilled upward, even slightly, they risked releasing millions of cubic meters of water into an enclosed underground space. The mountain would essentially implode from the inside. Tehrani proposed something no one had considered. Instead of avoiding the water, use it. Redirect the aquifer pressure through a controlled relief shaft system. Bleed the pressure gradually. Channel the escaping water into the canal's own supply network. Turn the catastrophe into an asset. It took 8 months to implement. It worked. The tunnel breakthrough happened on a cold morning in late November. When the final rock face was removed, workers stood in silence. Light passed through for the first time in geological history. Within 3 years, the first controlled water flow moved through the completed canal system. Not a river, not a flood, a steady, engineered current, carrying water from the Persian Gulf coast deep into Iran's landlocked interior. Ports that didn't exist before began construction. Inland cities received their first maritime trade access in recorded history. The project that should have failed at least 7 times didn't, and the world barely noticed. That's usually how the most important things get built, quietly, against all odds, by people who simply refused to stop. If projects like this fascinate you, there are dozens more hiding in plain sight.